In this video, we'll discuss on how to solve a problem using mesh analysis method. I am Joshua Daniel, Assistant Professor, Department of Electrical and Electronics Engineering, Hindustan College of Engineering and Technology, Coimbatore. Before we go to solve using a mesh analysis method, we need to know some basic laws like Kirchhoff's law, Kirchhoff's current law, and voltage law. We need to know how we can transform a source from voltage source to current source and current source to voltage source, and we need to know what is inspection method and normal method, right? So what is Kirchhoff's current law? The sum of currents flowing towards a junction is equal to the sum of currents flowing away from it. As you can see in this diagram, I1, current I4, I5 and I6 are the currents that are going towards the junction, and I2 and I3 are the currents that are leaving the junction. So they both are equal. Currents flowing towards the junction is equal to the currents flowing away from the junction. So what does Kirchhoff's voltage law say, which is shortly called as KVL? So here you can see a closed circuit which is formed by R1, R2, R3 and a voltage rise or a source that is denoted by V. We can find out the drops in each resistor by Ohm's law, that is IR1, IR2 and IR3. So we can write the sum of potential drops is IR1 plus IR2 plus IR3. We know the potential rise is from D to A and it is denoted as V. So as per KVL, we can write it as IR1 plus IR2 plus IR3 is equal to V. So coming to source transformation, how do we convert a voltage source to a current source? We know Ohm's law, V is equal to IR. So here we know the V and we know RS, the values of voltage and the values of RS. So we can find out a current source, that is I is equal to V divided by RS. So the value of RS is transferred here. So this is how we convert voltage source to a current source. Next, how do we convert a current source to a voltage source, right? So we know the value of I, we know the value of R. By Ohm's law, V is equal to IR. So we can find out the value of this voltage source, and it is noted here. And the value of this resistance is transferred and denoted as a series resistance connected to this voltage source. One more thing I want to add. So when you are noting down the arrow of this current source, you need to see the polarities of the plate. The upper plate is negative and the bottom plate is positive. So we note it as downward direction, right? Similarly, when transformation of current source to voltage source, if the arrow is downwards, you mark it as negative plate upper side and positive plate in the bottom side, right? These are some of the examples. So you can see how a voltage source is converted to a current source. So voltage is 120, resistance value is 6. So I is equal to V divided by R. So 120 divided by 6 ohm, that is 20 amperes. So this is the value of the current source, and the value of 6 ohms is transferred here and it is marked as parallel to the current source. Similarly, if you want to convert a current source to a voltage source, you have the current value as 40 ampere and the current and the resistor value as 0.8 ohms. So V is equal to I into R. So 40 into zero point 0.8, which is nothing but 32 volt, and the value of the parallel resistor is connected here as a series resistor as zero point 0.8 ohm, right? How do we denote the polarities of the EMFs or the sources or the voltage drops, right? If the current flows from minus plate to the positive plate, it is marked as plus V, and from plus terminal to the negative terminal, it is marked as minus V. And in voltage drops, right, if the current flows from in this resistor from positive to negative, it is marked as minus V. And if the current direction is from minus to plus in a loop, right, so it is marked as plus V. So when we solve using the inspection method, we need to follow some rules. So the first step is convert the current source into equivalent voltage source as we saw in source transformation. The next, we need to see how many loops are there and the total resistors in that particular loop are added, and it is denoted as R11. If there are any common resistor between any two loops, it is denoted as R12. Here we are considering for two loops and it is denoted by a negative sign. Right? Similarly, we have to note the drops with a negative sign. And for the voltage rises, as we saw how we need to note the polarities, we are denoting it. Right? Next, we need to see how the matrix is formed using Ohm's law for this mesh equation. Right? So we know V is equal to IR. So R11 will be the total resistance in loop 1. R12 will be total resistance or the common resistance between loop 1 and loop 2. R22 will be the total resistance in loop 2. Right? And I1 and I2 are the currents that we need to find out, and V1 and V2 are the voltage sources in that particular loops. So we can see here R1 plus R2. This is the total resistance in loop 1. R2 is the common resistance between loop 1 and loop 2, so it is denoted by a negative sign. Similarly, in the second loop, R2 plus R3. So the next one is a 3 by 3 matrix since we have 3 loops. Okay. Next, let us solve a problem using mesh analysis method and find out the different currents here. Right. So here we have 3 loops. We can see that there are 3 loops here. So we denote it with current I1, current I2, and current I3, and all are in clockwise direction. Right. Next, we need to form the matrix using inspection method. So in the first loop, we have 3 resistance, 1 plus 1 plus 1, which is nothing but as we saw R11 is the common resistance in or the total resistance in the loop 1. Similarly, the common resistance between loop 1 and loop 2 is 1, and we denote it with a negative sign. And the common resistance between the first loop and the third loop, we denote it with minus 1. And R21, which is nothing but the common resistance between second loop and the first loop. Between the second loop and the first loop, this is minus 1. R22, which is the total resistance in loop 2, right? 1 plus 1 plus 1. Common resistance between R2, that is loop 2 and 3, that is R23, right? 2 and 3, that is also minus 1. And coming to the third row, that is R31, R32, R33. Common resistor between 2 and 3, 3 and 1, 3 and 2, and the total resistance in the third loop. And we write I1, I2, I3, and we write the voltage sources in each loop, right? In the first loop, it is 10, that is minus plate to the positive plate, so we write it as plus 10. In the second one, it is plus 5 volt, and in the third loop, it is plus 5 volt, right? Next, we need to find out the determinants by using by applying Cramer's rule. We find the mesh currents I1, I2, and I3. So we denote it by delta, that is written as 3 minus 1 minus 1 minus 1 3 minus 1 minus 1 minus 1 3, right? So how we solve a determinant? So we know the columns. So in the first column it is plus sign, the second column is negative sign, and third column is a plus sign. Now, these are basics. So 3 into 3 into 3 minus of minus 1 into minus 1, that is nothing but 3, open bracket of 3 into 3 is 9, minus of minus 1 minus 1, close bracket, right? Then minus of minus 1 is plus 1 into open bracket of minus 1 into 3 minus of minus 1 into minus 1. So you can see it here. Then minus 1 into minus 1 into minus 1 minus of minus 1 into 3. So we get the value as 16. Next, we need to find out delta I1. How do you find delta I1? We replace the value of the first column with the voltages 10, 5, and 5. And as we found out for delta, the same method is followed here, and we found out the determinant as 120, right? So if you need to find out the current I1, delta I1 by delta, which is nothing but 120 divided by 16, which is 7.5 ampere. Next, we need to find out the current I2. So we need to find out delta I2. So here, how do you find delta I2? We replace the second column with the voltages 10, 5 and 5. And we follow the determinant method and we solve it and we find it as 100. So I2 is nothing but delta I2 divided by delta, that is 100 by 16, that is equal to 6.25 ampere. Similarly, to find out I3, delta I3, we replace the third column with the voltages 10, 5 and 5. Using determinant method, we solve it and find it as 100. So I3 is equal to delta I3 divided by delta, that is equal to 100 divided by 16, which is nothing but 6.25 ampere. So we have found out the currents I1, I2 and I3. Next, we need to find out the current through the different branches. So as you can see, there are 5 branches: AD, AB, BD, BC and CD. So how do you find out the different currents in these branches, right? So in branch AD, we have the current I1 flowing through this 1 ohm resistor as well as the current I2 flowing through this resistor. So we can write I1 is equal to I1 minus I2. We know the values of I1, I2 and I3. So 7.5 minus 6.25, which is nothing but 1.25 ampere, right? Similarly for AB, in branch AB, I2 is the only current, so it is 6.25 ampere. So in BD, we have I2 as well as I3, which is nothing but I2 minus I3 is 6.25 minus 6.25, it is 0 ampere. And in branch BC, we have I3 is the only current, so we write it directly 6.25 ampere. In branch CD, we can write it as I1 minus I3, which is nothing but 7.5 minus 6.25, that is equal to 1.25 ampere. Next, let us see another method of solving the, the circuit using mesh analysis method. So here we have 3 loops. We mark it as I1, I2 and I3, 3 currents. And here we use Kirchhoff's voltage law. So Kirchhoff's voltage law, we need to know how we marking the polarities, right? Discussed in the previous slides. So see, in the first loop, this current is flowing from minus polarity to the positive polarity, so 7. And the same current flows through the first resistor. So here two currents are flowing through this 1 ohm resistor. So I1 minus I2 into 1, right? Then the same current flows through the 6 ohm resistor, 6 volt source. So that is positive plate to negative plate. So it is minus 6. And in the 2 ohm resistor, I1 and I3 flows. So I1 minus I3 into 2, right? Since this is the major current, we are keeping that current as main, and then we minus with the second loop current, right? After solving, we get this equation. Let us see for the next two loops. In the second loop, we can see that two currents are flowing here. So here I2 is the major current, right? So I2 minus I1 into 1, 2 into I2, and when you take the third 3 ohm resistor, here I2 minus I3 into this 3. We know Ohm's law, V is equal to IR, right? So we are forming the equation like that, and we found out the equation. Similarly, applying the KVL for the third loop, right? So 6 volt. Then in this 3 ohm resistor, you have I3 minus I2 into this I3, then I3 into 1. Then here in this 2 ohm resistor, we have two currents. So I3 minus I1 into this 2. And finally, we solve that and we have three equations here, right? So solving these three equations using Cramer's rule, we already saw in the previous problem, right? Finding out the determinants and the values, and to find out I1, I2, I3, we need to know delta 1 and delta, and the similar method is followed, and we are finding the values of I1, I2 and I3, right? Hope you have understood the two methods of using inspection method and the normal method by mesh analysis method. Thank you for watching.